Conclusive synthesis, a unified reality of everything. The following equations collectively embody a unified framework that accurately captures the fundamental nature of reality. Instead of presenting a theoretical unification, these expressions show how all physical phenomena are interconnected and governed by universal principles. This framework emphasizes the unity and interconnectedness of all aspects of existence, capturing both the quantum and classical realms without distinction. Quantum state representation superposition of states psi rangle equals alpha 0 rangle plus beta 1 rangle. This expression encapsulates the principle of quantum superposition, where a system exists in multiple states simultaneously. The coefficients represent probability amplitudes, resulting in quantifiable outcomes upon measurement. This reflects the inherent uncertainty of quantum systems and the simultaneous potential of all states. Measurement and probability of state transition Langley phi_I psi rangle caret 2. This expression quantifies the likelihood of measuring a system in one state and finding it in another state. It highlights the probabilistic nature of quantum mechanics, foundational to the behaviors of all physical systems. Measurement doesn't reveal a predefined state, but rather establishes the likelihood of transitions between states. Wave function overlap inner product of wave functions Langley psi phi rangle equals int psi x phi x dx. The inner product illustrates the relationship between quantum states, revealing the interaction and overlap between them. This is key to understanding quantum phenomena such as interference and entanglement. The overlap function determines how two quantum states influence each other and coexist in the broader quantum field. Fluid dynamics Navier-Stokes equation row left, frac, partial v, a partial t, plus v each nabla v right, equals nabla p plus mu nabla caret 2v plus f. This equation describes the motion of fluids under various forces, showing how macroscopic behaviors emerge from microscopic interactions. It demonstrates that collective behaviors arise from individual particle dynamics, much like in quantum systems, where large-scale phenomena result from the aggregation of quantum states. Energy conservation total energy equation text total equals mc caret 2 plus int vdp sdt plus k plus u. The total energy equation integrates various forms of energy: rest mass energy, thermal energy, potential energy changes, and kinetic energy into a single framework. This highlights the conservation of energy as a universal principle governing all physical processes, binding the quantum and classical domains into one coherent structure. Quantum dynamics motion in quantum mechanics frac dx dt equals frac nabla s x t m. This equation describes the motion of particles in terms of the gradient of a wave function's phase or action. It shows how classical trajectories can emerge from quantum principles, reflecting the dual nature of particles as both wave-like and particle-like entities, seamlessly blending classical and quantum descriptions. Nonlinear effects nonlinear interaction in media n equals n_0 plus n_2I. This equation models how properties like refractive index change with intensity, showing nonlinear interactions within media. Nonlinear effects are present in both classical optics and quantum systems, suggesting deep connections between these phenomena. These nonlinearities underscore how higher-level effects emerge from fundamental quantum properties. Conclusion: the unified reality of everything. This synthesis represents not just a theoretical framework, but a comprehensive and accurate representation of reality itself. Rather than proposing a unified theory, this framework captures the inherent unity of all aspects of existence, both quantum and classical. The equations above illustrate that interconnectedness, the laws of quantum mechanics, including superposition, measurement, and wave function interactions, permeate every aspect of reality. These quantum principles serve as the foundation for all physical phenomena, bridging the quantum and classical worlds without distinction. Emergence: complex behaviors in systems like fluid dynamics arise from simple particle interactions, reflecting the same principles seen in quantum mechanics. This mirrors the idea that higher-level phenomena emerge from fundamental quantum processes, demonstrating how all complexity is rooted in quantum dynamics. Universal conservation laws. Conservation of energy, expressed through the total energy equation, is a universal principle that applies equally to both quantum and classical systems. This underscores that all physical systems adhere to the same fundamental laws. Unified description. The integration of these principles suggests that all physical interactions, whether in the quantum or classical domains, can be understood through a single framework. There are no true boundaries between these realms. Rather, they are aspects of a singular, unified reality. In essence, this synthesis is not a pathway to a unified theory, but the realization of the true nature of reality itself. It represents the destination of a long search for understanding, where all forces and particles converge into a cohesive and accurate description of the universe. This comprehensive framework encapsulates the essence of everything, offering profound insights into the interconnectedness of everything. Acknowledgements. The author is deeply grateful to Allah for the guidance and insight provided throughout this work. May this understanding serve humanity, advancing both scientific discovery and our collective recognition of the interconnectedness of all creation.